parallelogram has lots of properties, but you know, if I pick these two, will I get a parallelogram? If I pick some other two, or other three, will I get a parallelogram?
That's fantastic.
Plus, it also follows the Von Heel levels of geometric thinking. That first, it's identifying a shape, being able to choose a parallelogram from a collection of objects. Then, can you explore all the properties, rather, of a parallelogram? And then the last thing is understanding that these properties define it, as opposed to having just an exhaustive list of properties. So by doing that, you're going levels 0, 1, and 2 up Von Heel, and the research shows that most high school classes are taught at level 3, but most high school students are at level 1. So if you're teaching 2 levels above, they're likely not to get it. Whereas if you're teaching 1 level above, it's a stretch, but they can get there.
So right now I don't have anything happening on the Z-plane, but that's something I can write in as functionality. Like if you tap down, it could expose some sort of pop-up with information, or it can lock things together.
Parallel to blue, if I stay still. Okay.
And so one of the things I'd have to write in with the code is to actually be able to compare the X and the Y and the angles of the 2 different lines. You know, in the case that we were talking about with the parallelogram, if we did actually have 2 lines connected so that the students would actually be extending the line segment length as well as creating the angle, and then maybe dropping it down to a certain height to lock it in place,